Today we are going to study C++ templates. C++ template includes template functions and template classes. We first study template functions. We know that functions have parameters, and when you write a function, so you need to specify the types of these parameters. So, for example, suppose you write a function that swaps the value of two integer parameters. Of course, you need to use the reference, right? Call by reference. Otherwise, if you use call by value, then there's no impact for the parameters you give to them. You cannot swap them. So this function swaps the value of two integer variables. So what about swapping the value of two floats or two doubles? So now the question is, can we leave the parameter types unspecified when we write the function, and we let the compiler find the right parameter type when we call the function? So this is the mechanism to achieve this is C++ template functions. For example, so the definition of writing C++ template function is you first write template and then say class type X, and then the definition of the function, and parameter for the parameters you can use X to specify the parameter types. And here also this class X you can also say type name. And when you use this template function, for example, you just directly call this function, and for example, here we have two integers, then you just int, and you just give int to as the parameter of this function. And when the compiler compiles this function call, the compiler knows that int are integers. Then the compiler will know that this X means integer for this case. Here's another example that you have two doubles, and you call this function, you give X and Y to this function, and when the compiler compiles this function, the compiler knows X and Y's type are doubles, so both are doubles. Then the compiler knows that for this case, X is a double. Here's another example. You have two characters, X and Y, and when you actually here is A and B, and we want to swap this A and B. When the compiler compiles this function call, the compiler knows that A and B, these two parameters A and B, the type is character, then which means X is character. What if, for example, you gave this function call, for this function call you gave an integer and another type is different from integer, for example, say double. If you do that, the compiler will not compile. The compiler will throw out an error saying that no matching function call for this, and the compiler knows that I is an integer and D is a double for this case. Then the compiler looks for the definition of the function that the first parameter is the integer, second parameter is a double, and obviously this is not the definition of this function, and if you don't have such a function definition, the compiler will not be able to compile your code. Let's take a look at this example. So this is the function swap two variables, and both are type X. X is yet to be defined. And within this function, I can instantiate a variable temp, which is type X, and then I assign A to temp, and then B to A, and then temp to B. And let's see how we use them. Here, for example, I have I and J, both are integers. Then I can call this swap arguments I and J. And let's take a look. So here I is equal to 10 and J is equal to 20, and we print print them out before the swapping, and after we swap the swapping, let's take a look of the printout. Let's compile this, and we run. Okay, so you can see that before the swapping, I is 20 and J is I is 10 and J is 20, and after swapping, I is 20 and J is 10. So the swapping is correct. All right. So here you cannot give this function two integer values, because the function is a reference. The function is a reference to parameters, to variables. So this is a reference. So that's why you cannot give two integer values. Let's see what if you do that. If you do that, and you can compile. See, you see, this will not allow you to do that because they are expecting an integer reference, and you gave an integer, which is incorrect. The compiler will not be able to compile this. All right, so I is integer 10, the value, and here I define another variable d, which is a double equal to 1.5, for example. And what if I call this function swap arguments I and d, and see whether it can compile or not. As you can see, that no, cannot compile. It says no matching function for call to swap arguments, integer reference and double reference. You don't have such a thing. All right. Okay, so for a template function, so can we have parameters other than the template types? So here for this example, so we have this is function, template function, and he has two parameters, and both are type X. Can we have something other than this type X parameters? Yes. For example, template class X and void F. So two parameters. One is X, another is an integer. That's fine. Okay, another question: can we use X as a type name within the function? Of course, you most likely will need it. For example, in this case, when we swap to variables A and B, then we need type X as a temporary variable. Also, another question: can I use multiple type names? Yes, if all the type names can be determined from the parameter types. For example, so suppose here we have template X, and you can see that here swap arguments, and here the two parameters both are type X. So when you call this function, the compiler will be able to know what's the type of X. Now let's take a look at this example. So suppose we give class X, comma, class Y. But if you write swap arguments X, two parameters, both are X, then when you call this function, the compiler will now know what's the type, what's the type for Y. Then the compiler will not be able to compile this. But if one variable is type X, and if another variable is type Y, then that's fine, because the compiler can determine both for X and Y. Then you can have multiple type names. Another question is, can overload a generic function? So let's take a look at this example. Suppose we have template class X, voids will swap two arguments, both A and B, class X references. We can have another function, same name, both call swap arguments, and but different signatures. So here, although both are return types are void, but this the parameter types for this function definition both are class X, and for this one both are integers. Both are integers. Now take a look of when we use them. So here we are define two integers I and j, both are integers. We give x I and j to this function, swap arguments. Now you can see that it seems to make sense to call this function because in this case x is integer. It is also seems reasonable to call this function because both are integer. Then which one to choose? The compiler has to choose one. While the compiler chooses the one which is more specific. So which is more specific, which has high priority. In this case, this is more specific because both are integers. You explicitly specify the types of the two parameters are integers. And here is more generic because you specify them as the type of x. So x has to be determined at the runtime, and this is determined in the compilation time. So in this case, the compiler, this function call will call this one, will not call this one. All right, let's take a look at this second example. So we have two floats, and we gave two swap arguments, x and y. In this case, this will call this one because this one doesn't match, right? It has to call this function. And here x will be float. All right, let's take a look at this template bubble sort function. So suppose we want to sort something in a decreasing order, and x is a class, the name of a class, and here the parameter to this function is a pointer to a class X object, Okay, so here we first assign sorted equal to false. This is a Boolean variable, and we call items to get size, and first, if not sorted, then we assign sorted to be true, and then what we do is we go through the first element to the last element, and we see we always compare to consecutive ones. For example, initially this I-1 and I-1 element and ith element. If this one I-1 ith element is smaller than the ith element, then we swap them. Because this is in decreasing order, we'll swap them, and then we say sort is equal to false, and that's in this loop. Next time I will increase by 1, right? I will increase by 1. So after this round, from 1 to n, the last element, the nth element, will be the smallest element. So next round we do not need to consider the ith element, the last element. So we decrease the value of n by 1 here, and then we will start the next round of sorting. Okay, so just in case that you are not very familiar with bubble sorting, here's an animation. Which and I can show you. Okay, so all right, so let's take a look at this. So suppose this animation is actually sorting by increasing order, increasing or decreasing. Just when we do the swapping, it's different. All right, so starting from the first element, stepwise. In this case, so 15 is less than 20. We don't do the swapping, and next is 20 is bigger than 19. Then we do the swapping, and 20 is bigger than 3. We do the swapping. Bigger than 6, do the swapping. Keep going. You can see that after the first round, the last element is the biggest one. By the way, this is in increasing order. So then we start from the top again, and we do the sorting in increasing order. We'll compare them, and in this case, this 19 will, you see this one keeps going because this is the largest one. Okay, and start with again this 15, and then 17 become the bigger than this. 17 begin to keep going, and 17 is less than 18, and then 18 starts going. Because 15 starts going, and then 16 is less than 17. 17 starts going. You can see, so basically every round we got the last element will be the largest one, and in this next round will be among the n-1th element. Then the n-1th position will be the second largest, and the next round will be the n-2th element will be the largest, and so on. So that's the bubble sort animation. It's a pretty cool animation. Okay, so for this bubble sort function, this one can work with any class that has these three functions: get size, and also smaller, and also swapping. So this function called smaller, which you give the index of two index, and this function will compare whether these two index, so this one is smaller than the other element. So basically compare two elements, the value of two elements, and this is the value. This is function swap the two, and also you need to get size. What if when you call this function, what if you give a class name that don't have these three functions? Then the compiler will not be able to compile. Let's take a look at this bubble sort implementation. Here, okay, template class X, void sort decreasing order. This is class X pointer, and then you can see it called get size, called smaller, called swap. Okay, so, and let's see how we use this function. Okay, so here we have we implemented, say, integer vector, and because the standard vector doesn't have these three functions, doesn't have this get size, smaller, and swap. So we implement this integer vector, which use vector of integers to hold the data, and we implement this get size, or just return this vector size, and implement this swap, and implement this smaller. You can also have some other functions like print and so on. So, but these three you must have in order to use this, in order for the compiler to compile this template function. All right, so here we have this. When we use it, I instantiate a vector and push a few numbers into that, and use this vector to instantiate integer vector object. And when we call this function sort decreasing, we need to give a pointer to such an object. So we gave the address of this pointer object. All right, so let's take a look. So this one print out all the numbers before we do the sorting, and after we do the sorting, we print them out again. This is in decreasing order. So we compile this and print it out. Okay, so before the sorting we have 5, 4, 6, 10, and after the sorting will be 10, 6, 5, 4. So in the decreasing order. So what are the advantages of using template functions? Well, remember the software engineering principles. We covered several software engineering principles in the first lecture. Here it reflects a couple of software engineering principles. One is anticipation of change. So you are given a problem of sorting, say, integers. That's for today's task. Maybe after a few days, your manager may ask you to implement sorting for doubles, not just integers. Then if your program only works for sorting integers, then you have to write another program and you have to test it again. And also reflects the principle of generality. So when you are given a specific problem, say sorting integers, you should try to solve a more general problem, say using template, so sorting any values and of the same type. In that case, your code can be easily customized to today's specific problem, can also be in the future can customize to solve other specific instances of the similar problem. And by doing this, we basically promote software reuse. We can reuse the same code.